Okay, lesson 10-2, function operation and composition. So we've been evaluating functions where we plug in some value to see what answer we get out, evaluate, but now we're going to add, subtract, multiply, and divide functions, actual functions. So in this case, we're taking the function f, which is 3x minus 7, and the function g, which is 13 minus 2x, and we're going to add them together. We're going to find their sum. So we would rewrite this as 3x minus 7 plus 13 minus 2x, right? So here's the f function, here's the g function. We're adding them together. We're just going to combine like terms. So 3x and negative 2x is x, negative 7 and 13 is 6. So this new function is x plus 6. We could denote it as f plus g of x equals x plus 6. Okay, so right here, we're going to sort of rewrite the notation just to get a feel for what it means. So this, the quantity f plus g of x, is the same as f of x plus g of x. What I'd like for you to do is go ahead and pause the video and see if you can fill in these next 3 blanks. Based on what we've done there, I want you to make a prediction of what we're going to have in those. Okay, so difference would be f of x minus g of x. Does that match your guess? And then we have f of x times g of x. And finally, f of x divided by g of x. Okay, hopefully that pattern was pretty intuitive and you were able to discover what was going on there. Let's try out these first couple of problems. So here we have example 2 is f plus g of x. So this is really, we want f of x plus g of x. I'm going to start by writing f of x. And notice up here I have several equations, several functions. There's an f function, a g function, and an h function. So what we're going to do is first start by writing the f function. So I'm going to write x squared minus 8x plus 4. I want you to, if you need to, pause for a second and make sure that you know that that's the f of x function. It's coming from right there. That part needs to make sense. Okay, then we'll do the g of x function. That is 4x minus 3. Did you see where that came from? Here's our g function, 4x minus 3. Now we're adding 2 expressions, so we can just put like terms together. So this will be x squared minus 4x plus 1. Pretty good, right? Let's try example 3. On this one, we're finding f of x minus h of x. So f of x we had written before, and you can reference that on your page. X squared minus 8x plus 4. And h of x is x plus 2. Now we're subtracting. So this isn't just a matter of combining like terms. First we need to affect this entire set of parentheses by that negative. Okay, so we're going to have negative x minus 2. Now we can combine like terms. All right, let's move on to 4. This is the product of h and g of x. So we're doing h of x times g of x. H of x is x plus 2. The function g of x is 4x minus 3. So now we're going to multiply 4x squared minus 3x plus 8x minus 6. And so we have the simplified expression 4x squared plus 5x minus 6. For example 5, we're going to take f of x divided by h of x. F of x is x squared minus 8x plus 4. H of x is x plus 2. It is possible that we could factor this numerator and get an x plus 2 out of it and then simplify and divide something away. So let's check to see if it factors. A times c is 4, b is negative 8. So I know that 1 times 4 equals 4 and 2 times 2 equals 4. If I want to add and get negative, I guess I need to have both of these being negative. If I add -1 and -4, I'll get -5. -2 and -2, I get -4. I don't think there's any way I can get -8. So this one does not factor. That means that this is our answer. That's it. Okay, example 6. We're doing h of x divided by g of x. So h of x is x plus 2. G of x is 4x minus 3. I'm looking, is there something I can factor away from the numerator and denominator? The answer is no. Their greatest common factor of each of those is 1. So that's the end. All right, one more on this side. F of x times g of x. So f of x is x squared minus 8x plus 4. G of x is 4x minus 3. We're going to take x squared times each of those. So we'll get 4x to the third minus 3x squared. Now we'll take negative 8x times each of those. We'll get negative 32x squared plus 24x. And finally, we'll do 4 times each of those. So we'll have 16x minus 12. Now we can combine like terms. 4x to the third minus 35x to the second plus 40x minus 12. All right, let's take a look at the other side. 10-3. Okay, given these new equations, find each function. So here we're looking for the sum of f of -2 plus g of -2. This is sort of a combination of the 10.1 lesson and this lesson, right? So f of -2, I'm going to replace the x in the f of x function with -2. So I'll have 2 parentheses -2 squared minus parentheses -2 minus 12. Then I'm going to add that to g of -2. And g of -2 is, we're going to replace the x with -2, -2 plus 7. You could at this point put the whole thing in your calculator. I'm going to do a little mental math to figure this out. Got 8 plus 2 minus 12. 10 minus 12, that's -2. Over here we have 5. So I'm doing -2 plus 5. I think we should get 3 out of that one. Okay, example 9. We have f of 8 minus g of 8. So let's start with f of 8. 2 times 8 squared minus 8 minus 12. And then we're going to subtract whatever we get for g of 8. So parentheses might be a good idea here to sort of separate out the things. G of 8, that's going to be 8 plus 7. Okay, let's simplify f of 8 first. 64 times 2 is 128. Minus 8 minus 12 is minus 20. So I think we'll get 108 here. 8 plus 7, that's 15. So 108 minus 15 is going to be 93. F of -1 times g of -1. So f of -1, let's start there. We're going to do 2 parentheses -1 squared minus parentheses -1 minus 12 times g of -1. And g is 1 plus 7, so we're doing -1 plus 7. All right, I'm going to go ahead and just find each function's value and then multiply them together. So this will be 2 plus 1 minus 12. That's 3 minus 12. I think we get -9. -1 plus 7, that's 6. So I'm going to take -9 times 6, and we get -54. All right. 11, we're going to do f of 5 divided by g of 5. F of 5 is going to be 2 parentheses 5 squared minus 5 minus 12 all over 5 plus 7. Okay, to simplify the numerator, we have 25 times 2, that's 50, minus 5 minus 12, that's going to be 17, all over 12. 50 minus 17 is 33. If I divide the numerator and denominator by 3, I'll end up with 11/4. Okay, so that all was pretty intuitive, straightforward based on what we've seen. This next part is new. It's new information. We haven't come across this before. So here we're going to use composition. Okay, we're going to have a composite function that looks like this. And we can define that. Well, one distinguishing characteristic is this. It looks like a multiplication symbol, but hollow inside. That means composition. So it does not mean multiply. It's telling us to do this unique thing. What we're going to do is find f of g of x. And I want you to put in your notes to start here. We always want to start with what's inside and then work our way to the out. One other thing I want you to do is let's change this. Let's have the f of x function be x squared plus 8 instead of x to the third. I think that makes things, x to the third makes things unnecessarily difficult, so we don't need to bother with that. Okay, so this composition is telling us that we need f of g of x, and we're going to start with g of x. So let's just write that. G of x is x minus 1. So since we're looking for f of g of x, and g of x is x minus 1, we really want f of x minus 1. And what this is telling us to do is replace the x in the f function with that expression, x minus 1. So that will look like x minus 1 squared plus 8. If that didn't make sense to you, please rewind, slow it down, maybe pause, make sure that you're understanding each step before you move forward. Let's go ahead and expand x minus 1 squared. That'll give us x squared minus x plus 1. And don't forget this plus 8. So our final answer will be x squared minus 2x plus 9. Let's try 13. H of g of x. Start with g of x. That is x minus 1. Now our h function, 5x minus 3, we're going to replace the x in that function with our expression x minus 3. So that looks like 5 times that. There's our x replacement, minus 3. Let's distribute and solve. 5x minus 5 minus 3. So we get 5x minus 8. This is looking for f of h of x. Start on the inside. H of x is 5x minus 3. So we're looking for f of 5x minus 3. F is x to the third plus 8. We're going to replace the x with the expression 5x minus 3. Oh, sorry, I said change it to the second, plus 8. So 5x minus 3 times 5x minus 3 plus 8. 25x squared minus 15x plus 9 plus 8. So we end up with 25x squared minus 30x plus 17. All right, 15. I'm just going to change color. We're looking for g of f of x. So I'm going to start with the inside. F of x is x squared plus 8. So we're looking for g of x squared plus 8. I'm going to replace the x in the g expression with x squared plus 8. So we have x squared plus 8 minus 1. Okay. Dealing with order of operations, there's really nothing we can do until we separate the 1 from the 8. So it's just that. Okay, 16 has a slight difference. They have said instead of x, we want you to find g of h of 2. Start on the inside. Let's find h of 2 first. So h of x was 5x minus 3. H of 2 is going to be 5 times 2 minus 3, which is 10 minus 3, so it's 7. So we know that h of 2 is 7. I'm going to replace the h of 2 up here with 7. So now I'm looking for g of 7. I'm going to replace the x in the g function with 7. So 7 minus 1 gives 6. So I'm sort of doing two things, right? I'm doing h of 2, and then whatever answer I get in there, I plug it into the g function. Sort of like, let's see. Can't think of a word for it. That game, oh, like a scavenger hunt, where you go to one place to find one thing and then take that somewhere else to see what's next. That's sort of what we're doing here. So this, we're going to find h of f of negative 6. So let's start with finding f of negative 6. The f function is x squared plus 8. So we're going to replace the x with negative 6. 36 plus 8 is 44. So f of negative 6 is 44. Let's find h of 44. So we'll replace the x and the h function with 44 and solve. 5 times 44 is 220. 220 minus 3 is 217. All right, this should help you on your way with understanding the 10-2 lesson, function, operation, and composition.